So precise definition of limits is just one of those concepts that it's best just to go through a problem to explain how that concept works. So apparently it's not good enough for you to plug in 3, get 12, subtract 5, and get 7. That's not good enough for mathematicians. They want a precise way of doing it. So here's how we walk through this. How can we mathematically say that we're going to make x get closer and closer to 3? Well, the way we mathematically say that is that the quantity of x minus 3 will be getting smaller and smaller and smaller. So the way we frame that is with the Greek symbol delta right here. So if I approach 3 from the left, 2.99, 2.999, or if I approach 3 from the right, 3.1, 3.001, this quantity will just keep getting smaller and smaller and smaller and smaller. That is the idea of the delta here. Think of this as a sentence, an idea. So this is how mathematically we say, oh, x is becoming closer and closer to 3, by saying this. So now we need to say that the effect of this is that y will be getting closer and closer to 7. So if you make x closer and closer to 3, that will directly lead to y getting closer and closer to 7. That's sort of the statement we want to craft here mathematically. So we mathematically say this in a similar way as we did for x. We say that y minus 7 will be getting smaller and smaller and smaller. And this is the Greek symbol epsilon. And again, this also just represents the idea that of a quantity just getting closer and closer to 0, smaller and smaller and smaller and smaller. So y is just 4x minus 5. I mean, that's really what this equation is. Y is equal to 4x minus 5. So now my y statement is this minus 7 should be getting smaller and smaller and smaller and smaller. So we can do a little bit of algebra here. Negative 5 minus 7 is negative 12. And we can also factor out the 4 here. What we're trying to do is we're trying to find this idea somewhere in here. If we can prove that the idea that x is getting closer and closer to 3 directly causes this idea that y is getting closer and closer to 7, that will be our proof. And actually right here I found it. X minus 3, that's just our whole idea of the delta here. So I can substitute that. And now I've tied these two ideas together. So, as x gets closer and closer to 0, I mean, this delta is just getting smaller and smaller and smaller. Imagine taking 0.0001, timesing it by 4. You'll still have a number that keeps getting smaller and smaller and smaller, which is exactly what we need to satisfy. So if we make x closer and closer to 3, what happens as a result is y gets closer and closer to 7. We've linked these two ideas. If we had ended up with some sort of statement like this, however, that would not have been good. Because here, yes, x is getting closer and closer to 0. This is getting closer and closer to 0. But this 3 is just chilling there. 3 is not getting closer and closer to 0. So here, if we were to reach this point, the limit would not exist. So all those precise definition of limit problems tend to proceed in this manner. You start by making this statement, you make your y statement, and then you kind of work through the algebra and try to find that delta in your y statement. And you're trying to link the idea of the delta and the epsilon. Alright, hope that made sense. Feel free to ask any questions you may have in the comments. Precise definition of limits is just one of those really weird things. Let me know if you have any questions.